Hello students, I'm Arva, and in this video I have discussed about need for banking. Okay, we will discuss one by one point so that you will get a better understanding from every parameter, from every aspect. I will try to make you know what is the need for banking. First of all, students, objects in motion objects in motion Object in motion will tend to be or will stay in motion unless acted upon by external force. We know this property of inertia. This is the property by virtue of inertia. So now why I'm applying this law in the banking of road? Okay, why this is requiring the need this in this topic, this particular topic. So we again come to our main topic. You are in a car and you are traveling at a speed of 90 miles per hour. You are in the car. Okay, so it's non-inertial frame, so mv square by r is outward. Okay, so you are in the car and the car traveling at a speed of 90 mile per hour down a straight road. It's just a straight road. Okay, down a straight road. If you want to change a direction, let's say you are traveling in a straight road and then there's a sudden turn. Okay, so now you want to take a turn. That is, now you want to negotiate with a curve. Okay, you want to change a direction, you want to negotiate with a curve. Something has to provide you a push to change the speed of your car, to take a turn very smoothly. What do you think? Who will provide you this push? What do you think? Who will provide the push to this car? What do you think? Who is going to provide you the push? That is your car? No. The push that is only provided by the road. That's why this is on the push. This is the push. You want to now push. If you want to take a smooth curve and you don't want to if you don't want to disappoint that how I'll take a turn on a sharp curve, or just and want to make your speed constant, so what you have to do, that push is provided by the road. So what do you think? In what way the road will provide you the push? The road will provide, if you just bank this road, if you just take a upward, the car is moving in this direction. If just now this is straight and now you have to take the sudden turn. So what will happen if just this is a banked road? If road is like this, if the road is banked, look, this is the angle. So friends, what happens? So this road will give you the push. So what will happen if you just do like this? If the road is banked, this is angle theta, and then the car will go on very nicely. This is the banked road where the car will go. This push is provided by the road. So that push that we have to bank the road, this is the angle theta. So okay, I'll just show you with a video also. There's a video on it, and I will give you some pictures of it by making a drawing, so that you will get a better understanding of it. Look, this is our road, a smooth curved road. Okay, horizontal road, and there's a turning over it. So what will happen? Right now our car is like this. Oh sorry, our car, we got a wheel over here, and this is our car which is moving with a speed of v, and now it's on a turning point. It want to take a turn. Now imagine if a situation happens and there is a toppling condition, what will happen? Suppose the friction, this is the second use, second need of the banking. This is the second one. Now imagine if your car, if there's a toppling condition, what will happen at the time of toppling? So mv square by r will give a greater push as compared to mg. Mg on the, look, first I will draw the car. I will draw my car first so that you will get a better understanding of it. Okay, mv square by r, just try to take it out. Pull, this is a pivot point, and this is your friction which is inward, and this point is above the ground, and we have discussed this case earlier also. So mv square by r, try to, and this is a pivot point, and the car wants to topple now since because of friction. So what can you do now just to avoid the toppling? Suppose the road is smooth, the road is not smooth enough, so there is a need of banking. What you have to do, you just have to do one condition, that is, shall I draw it here? Okay, fine. Okay, look, this is my road, and now I will bank a road like this with an angle theta. Can you imagine? This is angle theta. This is up now. This is up. This side is up now with an angle theta. And now since this is the way, at this point the car wants to topple out, and the friction is of course just on this way, and the car wants to topple on this pivot point, and this is mg downward. Suppose this mv square is much larger as compared to mg torque, and then mg will also support after toppling. Just before toppling, if mg just counter attack in this direction, then it's fine. But what will happen in the worst case, when mv square is much greater than this force, then car will topple in this direction. So what you have to do, you just have to bank the road in this direction. So now your car will be like this and will go here smoothly. So theta is banking of the road is needed. Now third condition, which is a very nice condition. Suppose you don't have this, in the previous video I told you that this type of curve, at that time I told you that we have a very large radius, this very width, so it can take various radii, this, the car will have a various lane, like it can go in this radius, it can take various speed along this band. Okay, what will happen if we have such a roads, circular roads or flyovers? We know that if you have such a things that not it have very large width and which is very narrower width, so now you will not get enough radius. You have to be on point. So what do you mean by this? This is your car, mv square by r will be in this direction, F force, friction force will be in this direction, and look, friction has, since radius is very low here, so you cannot negotiate with radius so much. So now you have a very fixed, let's say you have a fixed radius, so you have a very fixed, if you have fixed radius, then centrifugal force is fixed. This means you have to take a speed which is equals to F limiting, that's it, because friction has also a limiting value which can hold you on the road. Otherwise, if you take a very large speed, if you take a slight large speed, then it's a very likely chance you will go outward, you will go to skid now. Okay, so at this condition, what you want to do is, this is the condition is space is less. Of course, the space is less. It means like space less kahan hoti hai? See, that is on the highway. Okay, and speed on the highway, you cannot negotiate with the speed so much. Speed is very high on the highway also. Speed is very high. You all must have experienced this kind of things. So speed is also very high, and simultaneously radius is very less. Okay, the friction cannot manage mv square by friction, which is a limiting friction according to this value. So friction also has a limit. It cannot manage alone. Friction cannot manage alone. So at this time, what you have to do is, friction cannot manage alone. So at this time, you need to bank a road. Why you need to bank a road? Because banking will provide you and one more factor, that is n sine theta, which will be in the direction of the friction. So friction and n sine theta will balance the mv square by r. So you will get two forces in this direction. Okay, I'll show you with this diagram. This is your banked road. Let's say it is at angle theta, and let's say now this is your car. Okay, so normal will be in this direction, okay, perpendicular to the surface. So here is theta and sine theta, and cos theta, and here will be n sine theta. Okay, and since we want a friction, this is a friction, wheels will be here. So friction, and this is mv square by r. Or more accurately, I will show you. Can you see the cross section is like just like a triangle? So let's have a triangle like this. This is our banked road. This is our car. This car on a banked road, and this will be n. This is our n. So sorry. Now okay, this is n sine theta, this is our theta, this is our n cos theta, and since this is our direction of friction, and this is our mv square by r. So friction force and n sine theta will be in same direction, which will balance mv square by r. So banking will give you extra force, extra factor, which helps you to be on the road. Now look friends, here for friction is adjusting. Friction will change, not adjusting, I mean friction, if friction will be in this direction also and will in this direction also. You can have, if a car suppose a car is going outward, so friction will be inward at that time. Suppose a car is going inward, so friction will be outward, friction will be in the direction, so that you will not go inward, to prevent you to going to prevent your car to going inward. Friction will come with mv square by r, and suppose if you are skidding outward, it means friction will at that time friction will be here, that is with n sine theta. So friction will change the direction according to the direction of the motion of your wheels. Look friends, this is a road curve. The car is moving like this. Okay, why we need a banking? This is a very simple rule. I will show you on this curved road. This is my curved road. Okay, imagine. Now let's say a car is moving over your curved road. Let's say, since this is the center, okay, then what will happen? mv square by r will be in this direction, and radius will be in, friction will be in this direction. That is wheels. This is the wheel. Wheel will try to move. Wheel will try to move along this. Okay, then friction mv square by r in this direction, and friction on the wheel will be in this direction. Suppose that there is a case of toppling. This is very rough surface, and let's say the car will topple now. So what happens at the time of toppling? Let's say this is mv square by r, so it will be more dominating force. The car will topple like this, okay. So this is the pivot point. This is the pivot point about which the car will topple and go like this. So what happens? What we have to do now, since always toppling will occur in a direction of mv square bias. Centrifugal force will try to take it out. So what we need, we just this is banking, okay, the car will go in this direction. So what you have to do, you just have to bank the road like this, theta, and the car will again come to its original position, that is on the road. So this is angle theta. So if the car is in this direction, just bank the road in that direction. You just have to bank the road in this direction, and this is the angle theta. So now the car, that toppling, when it is straight, when there is no banking, the car will topple in this direction, okay, the car will be like this. But as you bank the road, this whole thing, this wheel will be now, since this is banked, and this wheel will be going this direction. So banking of the road is there. So this is the need of the banking. So one of the main, there are so many reasons, but this is one among the reasons that why we need a banking. And if you don't want to topple it, and you want mg to be more dominating, then you can bank the road with angle theta. Of course theta is very less.